Welcome to the deep dive. Today we're getting into something really practical for anyone building machine learning systems. It's Google's rules of machine learning.
hmm
And this isn't just theory, right? It's more like a playbook, lessons learned from engineers actually doing this stuff at Google. What works in the real world?
Exactly. And what I think is so valuable about these rules
hmm
is how strategic they are. It's not just about chasing the newest algorithm, you
Right.
know.
Right.
It's about building smart, building effectively from the ground up. Good engineering applied to ML.
And that's what we want to unpack today. We're zeroing in on three big themes of these rules. First, this idea of thinking infrastructure first, why that's so important.
For sure.
Second, tackling training serving skew, that tricky problem where your model acts differently in the lab versus, out in the wild.
Oh, yeah, that one bites a lot of teams.
And third, just the core principles for building ML pipelines that are robust, reliable. These really feel like the foundations for making ML work.
Definitely. And to help us make sense of it all, we've actually got insights from a Google ML engineer who's lived these rules, can share some real-world context.
Perfect. Okay, let's dive in then. Starting with that first phase, the really critical part, getting a solid end-to-end pipeline setup.
Right.
And rule number one, well, it might seem a bit backwards at first. It's don't be afraid to launch a product without machine learning.
Yeah, it sounds odd, doesn't it? But the thinking is, ML needs data, lots of it, usually good data.
Okay.
And often you can get surprisingly far, get that initial momentum with simpler methods, heuristics they call them.
Like rules of thumb.
Exactly. Like ranking apps. Maybe just start by installs. That works pretty well initially. Or spam filtering. Just use a blacklist of known bad senders. Get something out there.
So the idea is don't let the idea of complex ML stop you from launching and learning and gathering that data you'll need later.
Precisely. Trying to force ML too early, maybe using data from a totally different problem,
Yeah.
it often just doesn't perform as well as a simple targeted heuristic at that stage.
Which leads neatly into rule number two. First, design and implement metrics. So even if you're launching without ML with just those heuristics,
You got to track stuff from day one.
why is that so critical early on?
Well, the rules point out a few things. It makes it easier to get everyone on board with tracking later.
Yeah.
Start building that historical data immediately, which is gold dust for ML.
Ah, okay.
And it forces you to actually think about how you'll measure success right from the start.
Yeah.
You design for measurability. You're not trying to bolt it on afterwards.
You understand your baseline, like what's normal for your system.
Exactly. What changes when you do things? What stays the same?
Mhm.
They mentioned the Google Plus example, tracking all sorts of engagement expands, reshares, comments.
Got a broad picture.
Yeah. And Rule 12 pops up here too. You need a proper experiment framework to actually trust those metrics.
Mm,
Otherwise, you're just looking at numbers without context.
right. So, okay, you've launched maybe with a heuristic, you're tracking metrics. When do you make the leap to ML? Rule 3 gives us a hint. Choose machine learning over a complex heuristic.
Yeah. The key word there is complex. A simple, understandable heuristic, great. Keep it if it works.
But when it starts getting messy,
Exactly. When you've got this tangled web of if this, then that, unless this other thing happens, it becomes a nightmare to maintain, to debug, to even understand.
right?
That's the signal.
Yeah.
ML, assuming you now have the data, can often be, believe it or not, easier to update and manage in the long run. Rule 16 touches on this too, the iteration aspect.
Makes sense. A complex set of rules is brittle.
Very. ML can adapt better.
Okay, so the time is right. You're building your first model. Rule number 4, keep the first model simple and get the infrastructure right. Focus on the foundation first.
Absolutely. That first model, its main job isn't necessarily stunning accuracy.
No.
No, its main job is to prove the infrastructure works end to end. Can you actually get data to the training algorithm reliably? Can you define what good and bad means for your problem, your labels? And crucially, can you plug this model into your application, whether it's live predictions or offline scoring? Get the plumbing right.
And keeping the model itself simple helps
Yeah.
with that verification.
Hugely. Simple features, simple model. You can actually check things more easily. Is the data flowing correctly? Is the model learning something sensible? Are the features being used right at serving time?
Yeah, I can see that.
The rules mention some teams even launch like a deliberately basic model first, almost just proving the pipes connect before worrying too much about prediction quality.
Which flows right into Rule 5. Test the infrastructure independently from the machine learning. You need to trust the pipes no matter what water flows through them.
Couldn't have said it better.
Hmm.
You need rock-solid confidence in those data pipelines.
And the rules get specific on testing, right? Like checking feature columns are actually getting populated.
Yep. Checking they have the data you expect, manually looking at the data going into training if you can, privacy permitting. That can be so revealing.
And comparing stats.
Yeah, comparing statistics from different parts of your pipeline. Does the data distribution look the same here as it does there? Little discrepancies can signal big problems.
And it's not just the input data.
No, you have to test the output too. The model itself, are the predictions you get in training the same as what you get in serving for the same input? Rule 37 hits this hard.
Training serving skew. We'll
Yeah,
come back to that.
Exactly. And can you load a known fixed model and get predictable results?
Yeah.
And don't forget testing the code that creates the training examples in the first place. That's often a source of bugs.
Okay, rule number 6 sounds a classic engineering pitfall.
Mhm.
Be careful about dropped data when copying pipelines.
Oh, it's so common. You think, great, I've got this working pipeline. I'll just copy it for this new, slightly different task. And you might accidentally drop data that was irrelevant for the first task, but is absolutely critical for the new one. The Google Plus examples they give are great. Copying the What's Hot pipeline for the mainstream, oops, they dropped all the older posts that were still relevant for the stream.
Right.
Or the Play Apps Home versus Play Games pages, copied the pipeline, lost the features that help tell different types of content apart. You're basically blinding your model without realizing it.
Yikes. Okay, rule 7 is interesting. It's about integrating old systems. Turn heuristics into features or handle them externally. So don't just throw away your old rules.
No, absolutely not. That knowledge is valuable. This rule is about smartly leveraging what you already have.
How do you do that?
The rules suggest a few ways. You could use the heuristic as a pre-processing step before the ML model,
Okay.
or you could take the output of the heuristic, maybe it's a score, and use that score as a feature in your new M model,
Clever.
or the raw data the heuristic was using. Maybe there are useful signals in there. Or even use the heuristic to help you define or adjust your training labels. It makes the transition smoother, keeps that intuition built into the system.
Smart. Okay, shifting gears slightly to monitoring. Rule 8. Know the freshness requirements of your system. How fast does your model go stale?
Yeah, this is fundamental for monitoring.
Yeah.
Does your model's performance degrade in hours, days, weeks?
And that tells you how often to retrain.
Exactly. And how closely to watch it. Something like ad serving or maybe Google Play search, like they mentioned, that changes super fast. Needs constant attention, frequent retraining.
Whereas other things might be more stable.
Right. Like the What's Hot example again, if the model isn't explicitly using time features, maybe the core patterns of what's popular change more slowly. Different monitoring cadence.
And rule 9 is about catching problems before they hit users. Detect problems before exporting models, pre-flight checks.
Absolutely critical. You do not want a broken model making decisions for users if you can help it.
So what kind of checks?
Basic sanity checks. How does the model perform on data it wasn't trained on, your held out set?
Yeah.
Are key metrics like AUC, that measure of discriminative ability, looking reasonable? Are they suddenly way off?
And you treat alerts differently depending on where the model is.
Yeah. Problem with a model still in training. Maybe that's an email alert. A problem detected just before deploying to users, or worse, in production. That might need pages, immediate action. Catch it early.
And Rule 10 highlights a really sneaky type of problem. Watch for silent failures. The ones that don't crash anything, but just degrade performance.
Ugh, these are the worst. They creep up on you. The examples about using stale data tables are perfect.
Like data that's just old.
Yeah, maybe a table you join against hasn't been updated in 6 months, like the Play example. Your model keeps running, no errors, but its predictions slowly get worse and worse because the world has changed and that table hasn't.
How do you even catch that?
It's tough. That's why tracking statistics about your input data over time is so important. And sometimes just manually inspecting the data and features periodically, it can save you from these slow burn disasters.
Finally, for this infrastructure section, Rule 11 is about organization. Give feature columns owners and documentation, basic knowledge management.
But so important in big ML systems. You might have hundreds, thousands of features. Who owns this one? What does it actually mean? Where does the data come from?
If the person who created it leaves.
Exactly. The knowledge walks out the door. Good documentation, clear ownership. It's essential for keeping the system maintainable and understandable long term.
Okay, solid foundation laid. Let's pivot now to that big challenge. Training serving skew. that gap between lab performance and real-world performance.
Right, where models look great in training but then don't deliver live.
Rule 29 offers a pretty direct solution. The best way to make sure that you train like you serve is to save the set of features used at serving time, and then pipe those features to a log to use them at training time.
This is a game changer for many systems. Log the exact feature values the model saw when it made a prediction live, then train on those logs.
So you're training on reality, essentially.
Exactly. It closes the loop. You guarantee consistency. The YouTube homepage example they mentioned showed huge improvements from doing this. Better predictions, less complex code. It's becoming a standard best practice.
Okay. Rule 30 is about sampling. Importance weight sampled data. Don't arbitrarily drop it.
Yeah.
So if you have too much data and need to sample down.
Don't just randomly throw data away. Well, you can usually discard data for impressions the user never actually saw. That's fine.
But otherwise.
Otherwise, randomly dropping data can skew your distributions. It can mess up your model's calibration, how well its predicted probabilities match reality. Remember Rule 14?
Right, calibration.
Importance weighting is the fix. You give more weight in training to the examples that were less likely to be sampled. It helps preserve the true distribution.
Got it. Rule 31 points out another subtle issue. Beware that if you join data from a table at training and serving time, the data in the table may change.
The time travel problem. You train your model, maybe joining against a table with user profile information, as it was on Monday. Then on Tuesday, the model is live. It sees the same user, joins against the same table. But the user's profile data in that table changed overnight.
So the input features are actually different, even if the core request looks the same.
Exactly, leading to potentially different predictions. The fix, again, logging features at serving time is best, Rule 32's point, or using point-in-time snapshots of tables for training.
And Rule 32 itself says, reuse code between your training pipeline and your serving pipeline whenever possible. Sounds like good software engineering, but maybe tricky for ML.
It is tricky because training is often batch, offline, maybe slower languages, while serving is online, low latency, often different languages.
So how do you reuse code?
The suggestion is to have a common layer, maybe define intermediate objects like representations of your features that both systems can create and understand. Then write shared functions to convert those objects into the final formats needed for training and serving.
Avoids duplicating the core logic.
Right. And they strongly advise not using totally different programming languages if you can possibly avoid it. Makes sharing code almost impossible.
Rule 33 talks about evaluation timing. If you produce a model based on the data until January 5th, test the model on the data from January 6th and after. Test on the future.
Yes. Evaluate on data that comes after your training cutoff. This mimics production much better. Your model has to generalize to data it's never seen.
The numbers might not be identical, but the trend should hold.
Exactly. Metrics like AUC should be reasonably stable. If performance tanks on that next day data, that's a big warning sign. Maybe your model overfit, or maybe the world is changing faster than your model can keep up.
Okay, Rule 36 is specific but important for recommendations or ranking. Avoid feedback loops with positional features. Position matters.
Hugely. Users click things at the top more often, right?
Sure.
So if you just feed the position, like slot #1, slot #2, directly into your model as a feature during training, the model might learn, oh, position 1 is great, just because it gets clicked a lot.
Not because the item itself is relevant.
Precisely. But then, when you're serving, you have to score all the items before you know their final position. So that powerful position 1 feature isn't available in the same way. Mismatch.
Leading to skew. So the advice is...
Keep positional features separate somehow. Maybe use them later in the ranking process or model the position bias explicitly. But don't let the core relevance model learn to cheat using position during training.
Makes sense. And finally, for skew, Rule 37 loops back. Measure training serving skew. You have to actually quantify.
You have to track it, and they break it down. Skew between training and your held-out test set. Skew between that test set and the next day's data.
Okay.
And crucially, the skew between that next day's data and actual live serving data. If that last one shows a big gap, that's almost certainly an engineering bug in your pipeline like Rule 5 hinted at. Something is different between your final testing and reality.
Okay, wow. Lots to unpack there on skew. So we've covered the foundation infrastructure and the big danger skew. Let's bring it together talking about building robust ML pipelines overall.
Yeah, this really ties it all together. The pipeline is the system in many ways.
And those early rules about keeping it simple initially, testing rigorously, Those are directly about robustness.
Absolutely fundamental. You can't build something robust on a shaky foundation. Simplicity and testing are key.
And Rule 16 reinforces that this isn't a one-and-done thing. Plan to launch and iterate. ML is continuous.
It's never really finished. You're always launching new versions, maybe adding new features, tuning things. Maybe the business goal itself changes.
So the pipeline needs to support that.
Totally. It needs to be designed for easy changes, for running experiments in parallel, for deploying updates frequently and reliably. Getting something working out there and improving it step by step is usually way more effective than aiming for perfection on day one.
Rule 22 is about hygiene. Clean up features you are no longer using. Don't let cruft build up.
Yeah, unused features are technical debt. They make the pipeline more complex, harder to understand, harder to debug. They slow down development of potentially better new features.
But you need to be careful what you remove.
Right. The rules mention thinking about coverage, how often a feature applies, but also its impact. A feature might only apply to 1% of your data, but if it's incredibly predictive for that 1%,
You might want to keep it.
you probably want to keep it or find a way to capture that signal differently.
And robustness clearly connects back to monitoring rules 8, 9, 10, and that idea of feature ownership and documentation from Rule 11.
Definitely. A robust system is one you can monitor effectively, one where you understand all the pieces, and one that doesn't silently break down because nobody owns or understands a critical component anymore. It's all interconnected.
The document mentions moving into ML Phase 2 feature engineering after getting the pipeline right. We're not diving deep into that today, but the robust pipeline enables it.
It's the prerequisite. You can't effectively experiment with and iterate on features if your underlying pipeline is flaky or broken. Good infrastructure makes good feature engineering possible.
So wrapping up this section, that well-built, well-tested infrastructure isn't just step one, it's the ongoing bedrock for everything else in ML deployment. It is the robust pipeline.
Exactly right. It's applying sound engineering discipline to the specific challenges of machine learning.
Okay, so as we wrap up this deep dive into Google's rules of machine learning, let's just quickly hit the main takeaways again.
Sounds good.
First, really focus on that infrastructure. Build it well, test it thoroughly, start simple to prove it works.
Yep. Infrastructure first.
Second, be hyper-aware of training serving skew. Actively measure it and use techniques like logging serving features to combat it.
Don't let skew undermine your work.
And finally, think of ML pipelines as living systems. Design them for iteration, keep them clean, make them maintainable for the long haul.
It's a continuous process, absolutely. These rules really offer a fantastic practical engineering mindset for tackling ML. It's less about magic algorithms and more about methodical, smart system building.
Really valuable perspective. So here's a final thought for you, the listener, to mull over. Thinking about your own projects or maybe just areas you're interested in, which of these infrastructure-first ideas, these anti-skew tactics, or these robustness principles feels like it could make the biggest difference for you? How could focusing on that foundation unlock better ML results down the line? Definitely check out the full Rules of Machine Learning document if you want to go deeper.
Well worth the read.
Thanks for joining us on the Deep Dive.